You look at page 415, example 2. It asks what solid is represented by the net. So again, making sure we understand what we're trying to find here. The net is a plane figure pattern which, when folded, makes a solid. So again, it's basically a flat form that we could fold up in order to make a three-dimensional object. So if we look at this on example 2, we can see altogether there are 6 sides. We might notice here they've got labeled a top and bottom. So having a top and bottom, we know it's going to be a prism of some sort. And then since those bases are rectangles, that would make it a rectangular prism. And so that's what that would look like if we would fold that up. Again, the goal here is that we recognize that would be a rectangular prism. Example 3, how can you draw a net of a rectangular prism that has a height of 2 units and bases that are 4 units long and 2 units wide? Okay, so we have a rectangular prism, so our net's going to look pretty much like the last example. Height is 2 units, bases are 4 units and 2 units. So you can see they started off with the bases kind of starting here. This is a 4 by 2, so 4 squares going the one direction, 2 squares going the other direction. And again, these rectangular prisms, we can actually draw them. They kind of look like a cross depending how we have these turned. If we turn this 90 degrees, basically rotating it like that, then it kind of looks like a cross. So we have 4 rectangles, and then the sides we've got here. The height is 2. So we basically just go right up against this rectangle, and then this part, this blue line I'm drawing, that's how we get a height of 2 when we would fold this up. If we look at the try it, they want us to identify this solid from its net. This one, if you'll notice, there are not 2 bases that would be parallel if we kind of think about this. Remember, the middle of this net is going to be our base, and then we kind of see from there how things are going to work out. So this one, that red triangle being the base, we could actually fold those other triangles up, and we could get our shape here. First of all, they've got some preliminary questions here, though. The shape of the polygonal faces, so the shapes of these faces, shapes of these sides would be triangles. The shape of the base, which is that red triangle, obviously is a triangle. And then this is a net. Since those fold up, they would actually meet at a point. We wouldn't have parallel top and bottom, so this would be a pyramid. So our base is a triangle, so this would be a triangular pyramid. So the key concept, kind of recapping what we talked about, how we can use nets to represent these figures. Again, this would be a rectangular prism, kind of looking like a cross as a net. Again, to emphasize, this is the net when it's unfolded. And then over here we've got a pyramid. This pyramid, the base, that green side, looks to be a square. Again, just to be safe, if you want to call this a rectangular pyramid. If they marked the sides for us, to where we know all these sides are the same, then we definitely could call this a square pyramid. So if we look here, we're going to look at the do you understand. Number 3 asks us to explain the difference between a pyramid and a prism. And again, once again, we talked about earlier is that prisms have 2 parallel bases, and prisms have 2 parallel bases, and pyramids only have 1 base and come to a point. We look at the do you know how. Number 5, they want us to classify these. So again, we're looking at number 5, thinking about first of all if it's going to be a prism or a pyramid. We can see this one coming to a point, so it is going to be a pyramid. And then we look straight down from that point, look at what the side is, what shape that is, and it's a triangle, so that would be a triangular pyramid. Again, on pyramids, the sides are always triangles. It's just a matter of what the base is. So triangular pyramid. If we look at number 6, we can see we do have a top and bottom here that are parallel. So that would be a prism. And then that would actually be then, since our top and bottom are rectangles, that would be a rectangular prism. Looking at number 7, they want us to identify that solid. So this one, again, the base is going to be in the middle of our net. So we have our base there. And then if we can think about what's going to happen if we fold the rest of this, the rest would fold up, actually come to a point. And so this would be, we could call it, to be safe, a rectangular pyramid, because that base, that red side, is a rectangle. So rectangular pyramid. This one, if we count our squares, we could possibly call this a square pyramid as well. Would be okay. Number 8, again, looking in the middle of this figure, we have a rectangle. So we might look at that and say, well, that's going to be our base. It's actually different on this problem, though. So this one, if you can kind of visualize, actually thinking about that red rectangle there and then kind of folding the other pieces up, what's actually going to happen is these triangles on the sides are going to end up being parallel to each other. So we have 2 parallel sides, they're triangles, so this would be end up actually being a triangular prism. So triangular prism, again, triangular prisms, it's something like this when we draw that out. Okay, so most of the other cases to that point, we could always just look for that middle part being the base. This would actually be an exception to what we've seen there. Number 9 asks us to draw a net of a rectangular prism that has a height of 2 units and bases that are 3 units long and 1 unit wide. So rectangular prism is going to be like that cross-shaped net that we've been talking about. Height of 2 units, and then the bases are 3 units long and 1 unit wide. So we can start out with that base. The base we might want to put somewhere towards the middle. So 1 unit wide and 3 units long. So this could be a base, what's going to happen then, we're going to have there will be a side next to that base. So the sides are, well, it has a height of 2 units. So we just go right next to this base here. This is our base. We go right next to that. We have a side. It's going to be 2 units high. So we have to go 2 squares from there. And we'll make that into a rectangle. We know rectangular prism, all the sides on a rectangular prism, all the faces are rectangles. So this would be a side. And then our next part, if we want to continue this direction one more, the next part, the next piece here would be our other base. If we want to make this kind of a cross shape here. And then we go up, we're going to need another side. That would have a height of 2, so we go up 2 from there. That would be one of the other sides. We know rectangular prism has 6 sides, so we've got a total of 4, 6 faces, we could say 4. We've got taken care of. We need 2 more. So again, a height of 2, we have to go 2 blocks out to one side and 2 blocks out to the other side. And that kind of finishes off our cross here. So those 2, and then if you can imagine this folding up, when we fold this up, it's going to look something like this, rectangular prism. We look at some problems here on your workbook, page 101. Number 1, they're wanting us to classify these figures. So number 1, we can see this does not just come to a point. We've got 2 parallel bases. And the shape of those are triangles, would make this a triangular prism. Look at number 2. This one does look like it comes to a point, like these things maybe we've seen in Egypt before, videos or something. And then this one, the base at the bottom there is a triangle, so that would be a triangular pyramid. And then number 3 also comes to a point. This time the base at the bottom there looks to be a rectangle. The book's calling this here a square pyramid. Again, to be safe, maybe calling it a rectangular pyramid. 4 through 6, they want us to identify these solids from the nets. Number 4, they've constructed this where it looks actually a little bit different. If we look at it, there are 6 different rectangles on this figure, and so it's a little bit different look, but this actually would be a rectangular prism. Again, basically they just kind of shifted this side down. It could have been put up here next to this, but that's fine. That's just a different look for us there, rectangular prism. Number 5 is more like what we've been seeing, kind of almost a cross shape there, kind of a wide cross here, but then that would be a rectangular prism as well. And then number 6, if we think about what's happening there, when we fold these sides up, think about keeping this side down, folding the other sides up kind of next to that. What's going to happen is that's actually is going to create a triangular prism. Those triangles, once again, will be parallel to each other. Number 7, Josh is going to draw a net of a triangular prism. How many rectangles should there be in his drawing? If you look back at the problem we just did there, number 6, you can see for a triangular prism there would be 3 rectangles. We need 3 rectangles and 2 triangles. And then number 8, Monique is going to draw the net of a triangular pyramid. How many triangles should there be in the drawing? Triangular pyramid, our base would be a triangle, and then we would have some triangles that would come up from that. So that actually would need to be 4 triangles. Number 10, if we look at this, Eli drew this net for a triangular prism. Explain why Eli's net is not correct. Basically, it's just that he forgot one of the rectangles over here. Number 11, they want us to classify this, name all the vertices, edges, and faces. So this one, we could see this would be a triangular pyramid. We're not going to worry as much about naming all of these things as telling how many there are. So vertices are like corners. So you can see at the bottom we'd have 3 plus 1 on top. So there would be 4 vertices. The edges I'll draw in red here. 1, 2, 3, 4, 5, 6 edges. And then the faces is how many sides there are. There's the base is a triangle and then 3 more, so that's a total of 4 faces. And again, we talked about faces plus the vertices minus the edges should equal 2. Number 12 says if the top of a pencil box is 8 inches by 3 inches and the side is 3 inches by 2 inches, can you find the dimensions of the front of the box? So we can kind of label some things here. 8 inches by 3 inches, and then this side is 3 inches by 2 inches, so we got the 3 already, there'd be a 2. Can we find the dimensions of the front? So the answer is yes. You can see already there would be a 2, and then if this is 8, then this would also be 8. So our dimensions would be 8 inches by 2 inches, or 2 inches by 8 inches. So this gives you an idea of how to represent solid figures using nets.